into the infinite. What are neutron stars? Neutron stars are the remnants of massive suns that died in fiery explosions. What's left behind is smaller than a city, but heavier than our entire sun. These stars collapse so tightly that their atoms are crushed. Protons and electrons merge, forming pure neutrons. A cosmic neutron ball. A sugar cube-sized chunk of neutron star would weigh 1 billion tons. They spin fast, insanely fast, sometimes hundreds of times per second. Their gravity is intense enough to bend light and warp time. Some shoot out powerful radio beams like lighthouses in space. We call these pulsing versions pulsars, blinking on and off in rhythm. They were first detected by accident and briefly thought to be alien signals. Neutron stars come from supernova, the death cry of giant suns. When the sun explodes, its core crushes in and becomes this dense relic. If it had any more mass, it would have become a black hole instead. But a neutron star holds the line, an object on the edge of collapse. Their magnetic fields are trillions of times stronger than Earth's. These fields twist and snap, sending waves of energy across the galaxy. Some neutron stars are so powerful, we call them magnetars. Magnetars can disrupt electronics from thousands of light years away. These exotic stars rotate with extreme precision, down to the millisecond. Astronomers use pulsars as cosmic clocks to measure time across the universe. Even as they slow down, they pulse with eerie accuracy. Some neutron stars live alone, drifting silently in space. Others orbit companions, siphoning matter from nearby stars. When this happens, they flare up, emitting X-rays and deadly radiation. Neutron stars challenge our understanding of physics. They contain matter so dense we can't replicate it on Earth. The surface is a solid crust of nuclear material. Beneath that crust lies a liquid ocean of neutrons. And below that, possibly, an exotic core of strange matter. We don't fully understand what lies at the center of a neutron star. It might be the closest thing to a black hole that still has a surface. Their gravity traps nearly everything, but not light, not yet. And still they're small, only 10 to 15 miles across. If Earth were crushed to that size, it would become a neutron star too. They move fast, hurtling through space at millions of miles per hour. Some have been clocked faster than any other object not using rockets. When two neutron stars collide, the universe trembles. These collisions send out gravitational waves, ripples in space-time. They also create gold, platinum, and other heavy elements. Yes, the gold in your jewelry might have come from a neutron star smash. The 2017 neutron star merger was the first event seen in light and gravity. It confirmed decades of predictions and blew open new areas of science. Neutron stars are not just dead stars. They're cosmic engines. They shape galaxies, seed planets, and tell time across dimensions. Each one is a laboratory of extreme physics. They challenge Einstein and Newton in the same breath. Our telescopes can't see their surfaces directly, only their emissions. But we can map their spin, their light, and their effect on nearby space. In deep time, they cool and fade, becoming black dwarfs if left alone. Yet in some scenarios, they reignite, triggering fresh collapses. These zombie stars refuse to stay dead. They're stars, but also something entirely different. They're not hot enough for fusion, but too dense to ignore. And even though they're dead, they still influence living stars. Some neutron stars are in binary systems, dancing with partners. Others drift, invisible, until they suddenly appear in a burst. The universe is littered with their ghosts. We found thousands, but millions more may roam, unseen, unmeasured, unimagined. To find them, we listen, not with eyes, but with radio waves. Some emit like a heartbeat, others just whisper and vanish. The signals they send can travel across the universe untouched, Time itself ticks to their rhythm in the depths of space. Even black holes can't pull off that kind of stability. Neutron stars balance on the edge of impossible. They are heavy, silent, ancient, and relentless. Their existence proves that death in space is never simple. It's messy, brilliant, violent, and sometimes still pulsing. In the scale of cosmic history, neutron stars are the echo of giants. What they leave behind shapes the galaxies we live in, and understanding them brings us closer to understanding ourselves. Because in their silence, they tell stories of life, death, and eternity. This is the mystery and majesty of neutron stars. Subscribe for the next journey into the infinite.